Hello class. Today we're going to review the homework I gave yesterday. It is day 22 of Coronachem, Tuesday, May 5th. First question you were assigned was 2019 B, where permanganate is reacted with methanol to give you the manganese ion and formaldehyde, or also, not formaldehyde, methanoic acid. Formic acid is given as a result. So methanol is oxidized to methanoic acid, and permanganate is reduced to the manganese ion. First thing to do is to set up the half reaction. So the first half reaction is permanganate turning into the manganese ion. So what I start off with is this and this written on that line. And then I noticed that there was 4 oxygens on the left and no oxygens on the right. So what I did is I added 4 water molecules to counterbalance those 4 oxygens. Then, because there's 2 hydrogens for every water molecule, 4 times 2 gives you 8 hydrogens on the right hand side and 0 hydrogens on the left, so I put in 8 hydrogens to balance that out. And then I looked at the charges. Just pretend this part wasn't here yet. There was a negative 1 here and a positive 8, so it's plus 7 on this side, and it was plus 2 on that side. So to bring the plus 7 down to plus 2, I added 5 electrons. And that's the first half reaction balanced. The second half reaction is the methanol being oxidized to methanoic acid, or also known as formic acid. It's what ants, stinging or fire ants release in their bite. That makes the sting, it makes the bite sting extra. Is this chemical here, formic acid. That's where we get the name. Formica is the Italian word for ant, perhaps also Spanish. I think they were found in South America. Anyway, the methanol turns into methanoic acid, so there's one oxygen here, but 2 oxygens there, so we're going to add 1 water molecule to balance it. And then count up the hydrogens on the side where you just added the water. You're going to see have 3, plus 1 is 4, plus 2 is 6 hydrogens. And there's 2 hydrogens on that side, so if you add the 4 H pluses over here, it balances out the hydrogens. Then check the charges. There are 4 positive charges on this side, no charges on that side, so by adding 4 electrons like I did here, I've balanced out this side so it has the same charge as that side. Now, this reaction has 5 electrons and that one has 4 electrons, so what I did is I multiplied the first reaction by 4 and the second reaction by 5, added the results, and then canceled out anything that would cancel out either fully or partially. The electrons obviously cancel out fully because I'm trying to get the same number of electrons by using this multiplication. The effect on the hydrogens is that I went from having 8 hydrogens. When I multiplied it by 4, I got 32 hydrogens on this reaction, and I got 20 hydrogens on that reaction, so they partially cancel so that you have a net amount of 12 hydrogens on the left over here. Looking at the water, 4 times 4 gives you 16 hydrogens on the second reaction. Sorry, 4 times 4 gives you 16 waters on the first. Why did I put 5H2O there? I'm just noticing now. Something is off. H2O and then 5H2O. Right, so 4H2O and 5H2O. Oh, that's right. What happened is, in the first, all the stuff that's before the arrow is coming from these two. all the stuff that's after the arrow is coming from these two. So 4 times permanganate, 4 times hydrogen gives you the 32 hydrogen, 4 times 5 electrons gives you 20 electrons, 5 times the methanol gives you 5 methanols, 5 times the water gives you 5 water. Then on the after the arrow, 4 times manganese ion, 4 times 4 waters gives you 16 waters, 5 times methanoic acid or formic acid gives you 5 formic acids, and then 5 times hydrogen gives you 20, and 5 times the other 4 electrons gives you 20 electrons. So now that it's balanced, I can cancel out 32 hydrogens with 20 hydrogens to give 12 hydrogens. I can cancel out the 16 hydrogens with the 5 hydrogens to give 11 hydrogens, and the rest doesn't cancel, so this is the final answer you get. So you're following the steps. First you write half reactions, then you balance the oxygens with water, then you balance the hydrogens with protons, then you balance the charges with electrons, then you balance the half reactions with integers if necessary, and in this case it is, and finally you write it in the net reaction, having canceled out anything that does cancel, and then write in the phases to give the final answer. The next question that you had on for homework was 2019 C. In 2019 C, starts off with iodine and hypochlorite reacting to give you iodate and chloride. So the iodine is oxidized to iodate, and the hypochlorite is reduced to chloride. So the first half reaction, you have the iodine and the iodate. So you just, starting off, you only had these two things. So first I balance off the iodines. There's 2 iodines here, so I had to put a 2 in front of iodate. Then because I have 2 times 3 oxygens, that's 6 oxygens, so I had to put 6 waters on the left to balance out the 6 oxygens that are on the right. By putting 6 waters on the left, I create an imbalance of 12 hydrogens, so I put 12 hydrogens on the right to balance off the 6 waters. And finally, I balanced out the charges. There's 0 charges on the left side, there's 2 negative ones, and 12 positive ones. So overall on this side you have a plus 10, this side you have 0. So to bring this side down to the same as this, you'd have to add 10 negative charges, so I added 10 electrons. On the second equation, I put hypochlorite turning into chloride. And there's 1 oxygen over there, so I added 1 water. By adding 1 water, I created an imbalance of 2 hydrogens, so I added 2 hydrogens to balance that out. Then I looked at the charges. The total charge on this side is plus 1, because plus 2 minus 1 gives you plus 1. And the total charge on this side is minus 1. So to get from plus 1 to minus 1, you can add 2 electrons. Now this reaction, this half reaction, requires 2 electrons, or rather this reduction requires 2 electrons. This oxidation puts out 10 electrons. So basically this reaction has to run 5 times to produce the same number of electrons as this one releases. Or this one has to, sorry, this one has to run 5 times to use up as many electrons as this one releases when it runs once. So I multiplied this whole reaction by 5, and now I'm about to add the result. So we're going to say I2 plus 6H2O plus 5 hypochlorite plus 10 hydrogens plus 10 electrons yields, and I'll stagger it that way so we have enough room to put everything in, 2 iodates plus 12 hydrogens plus 10 electrons plus 5 chlorides plus 5 waters. Okay, so the electrons will cancel. The H pluses will partially cancel, so that 2 will be left over. And the 6 waters will partially cancel with 5 waters, so that there's then 1 water left. And now we can write the final result, which hopefully you can see. Well, I'm going to have to lower it one more step. Okay. So the final result, and you write in the phases to show it, is I2, I'm guessing it's solid here, plus H2O liquid yields, plus H2O liquid plus 5 hypochlorites yields, and that's going to be aqueous, sorry, yields 2 iodates plus 5 Cl minus plus 2H plus. Both of these aqueous. Okay. The last one I asked you to do for homework was to be balanced in basic solution. So I'm going to erase the board and show you how to do that one too. Wow, looks like the green ink. It's a little harder to erase. I was going to use my new board, which I got delivered to my door, but I realized that you have to stick it on with a backer, this sticky backing, and if I do that here, I'm going to have to transport it fully extended. It's not going to be convenient, so I'll wait to set it up until I get to the farm. So the last question I had given for homework was 20D, and I had asked you to solve it under basic conditions